Hi students, in this video we're going to go over setting up Solidworks to do drafting. First thing I'd like you to do is come over to the lesson 10 on the website. I want you to download B-size sheet 2 format .slddrt. This is going to be the file you use when you want to create more than the standard number of drawings. I'd also like you to download piece part drawing template .drwdot. This is going to be the file which will be your initial drawing creation for each and every drawing. So download those, put those into your folder. And as you can see, I've done that here. So here's my SolidWorks templates 2018, the piece part template, and B-size sheet 2 format. So now I'm ready to begin drawing. Minimize that. And we'll go back over to SolidWorks. So the first thing I'm going to do is open the part that I want to draw. Oops. Turn this onto part files. Okay, so here's a part that I'd like to make a drawing of. The way I'm going to do that is I will say File, Make Drawing from Part. You'll notice that under my Templates tab, the piece part drawing comes up. Okay, that looks good. Okay, I have views set up to come in automatically, and they may not come in correctly or where you want them, so we're going to have to make some adjustments. First thing I'm going to do is I see a bunch of whole callouts with lowercase lettering. We always do all of our lettering in uppercase, so I'm going to delete those. I'll delete this view, delete that view. I will simply drag this view down a little bit. This isometric I don't really care for, plus it's in the wrong position, so I'll get rid of that. This view is quite large for what I need, so let's look at changing the scale. I've clicked on the view, and over here in the view manager, I'm going to say use a custom scale. So instead of 2:1, maybe I'll go with a 1.5 scale. That gives me a little more drawing room. Remember, we never ever want to put graphics under the revision block. So that leaves only this area and down below to put our graphics in. So let's keep going. I'm going to add another view so that I can fully define this object. I'm going to say Insert, Drawing View, and Project it. Now, every time I drag outward, a new view is created. Fell out of my command. Okay, that looks pretty good. Notice, the views all move together, and they all line up according to the flaps on the glass box. Your isometric is typically in a smaller scale than all your other views. This is just a viewing aid. So we're going to make it smaller, and we're also going to turn off the hidden lines. To turn off the hidden lines, come down to Display State and click on Hidden Line Removed, and you'll see it immediately starts looking solid. The scale, we're going to use a custom scale on this. See what half scale looks like. That's not too bad. I'm going to ask that you always put your isometrics in the upper right-hand corner. Whenever you have a hole, make sure that you always put center marks on your holes. So I'm going to come up to the top. I'm going to click on center mark. I'll click on the hole edge and drop in a hole. Okay, that looks nice. When you start detailing your model, I like to start with doing the overall dimensions first. We're going to put our dimensions on by using smart dimensions. I'll put the height of the object, the width of the object, and the length. Now a machinist knows exactly how big a chunk of metal they need to start with to get their part. From here, we're going to locate each and every feature. Remember, you must provide enough detail that the part could be made from your drawing. And when you detail, you want to give exactly one dimension for every feature. You do not ever want to double dimension the location of an entity. So I'm going to zoom in a little bit. I'm going to measure over to this hole, measure down from the hole. It's okay to put your dimensions over the drawing itself, or over the part view rather. I'm going to come over here, and again I'm going to locate my hole relative to the edges. Now, I see a bunch of dotted lines around the holes. That means it's threaded. Plus, I also need to put some kind of a diameter call out. I need to tell the machinist how to make this hole. I'm going to do that with the hole call out function. So the first line is telling me here's the tap drill size. I'm going to use a 0.422 and drill through the entire part. And then I'm going to tap it, or create threads, which are 1/2 inch in outer diameter, 13 threads per inch, according to the Unified National Course Standard. I'll do the same thing on the opposite hole. That's starting to look pretty good. Now I need to tell the machinist what to make this object out of. So I'm going to put a material note in. I'm going to say notes, and I will number them. And always put a material with an alloy. So for example, I could use 1010 steel. This is a very common low carbon steel. So that's what your material note should look like. Now you'll notice that I've put in 3 views, but I have no dimension on the top view. I can delete this. I have my part fully defined based on these 2 views. So I didn't need it. That top view did not tell anything in the story. Okay. So as a general cleanup, if you don't use sheet 2, please delete it. We'll get rid of that. Now let's look at the title block. Make sure your title block is filled out properly. So drawn by S. Abadessa, that's me. Today's date, I will double click on this, is 10/21/2018. The sheet scale, or excuse me, the view for the the scale for the views. Come down, double check. So I use 3:2. So I'll have to modify this. 3:2. This is sheet 1 of 1. Now these other items, the drawing title, the part number, and the revision, this data is all being pulled from the model. So if I want to change any of that, I have to go back into the model. I can do that simply by opening the model. I can do that from my drawing manager. I'll say open part. I'll go under File, Properties. Here are all the same entries. So I could change this to the revised block, part number 9000. I'll make it Rev 1. I'll say OK. Save it. Close the part. And my drawing all updates. So if you handed this in, this would be full credit. My part is fully defined. The hidden lines are turned on in the glass box view. The hidden lines are turned off in the isometric. I know what material to make it out of. So this is a perfectly acceptable piece part drawing at this point. Let's go on to a slightly more difficult part. I'm going to open the class example wedge. Okay, this part is a little bit more difficult because we have a face that doesn't align perfectly with the glass box flaps. So let's see how we're going to handle that. Again, we'll make a drawing from the part. And things didn't come in exactly perfect, so I'm going to delete that isometric. I think I'll delete this view, and I'll delete this view. I'll put my isometric back in by saying Insert, Drawing View, then Project it. So I'm dragging upward at a 45-degree angle to create the isometric. I'll click on the view. Again, isometrics always have their hidden lines turned off, and most of the time they're at a different scale than the rest of the views. Often it's at a smaller scale. I'm going to go quarter scale. And I'll just put that up there and say OK. So I think I'll start off by adding a right side view. As always, I'm going to start by defining the limits of my part so that the machinist will know how large a piece of metal they need to make the part. 3. There's the length and the width. Okay. All of my holes should have center marks. Any cylindrical faces should have center lines. The way I put those in, I'm going to come up and use the center line command. I'm going to zoom in a little bit more. And I'm picking 2 parallel faces or the outside edges of a bore. And there's all my center lines. I'll say OK and exit that command. Now I need to locate each of the features. So this first counterbore hole, I'm going to dimension over from the edge. And up. I'll say OK. So now I have this hole located. I also need to tell the machinist how to make that hole. So I'm going to put in a hole call out. There's all the information that the machinist needs to make that hole. Now we need to address another issue. We'll address how we're going to handle this face and the location of the two holes on that face. Let's start by going from the end point of the part to the center line. Now we never, ever, ever dimension to a hidden line. But for the sake of this example, I'm just going to look at the distance to that center line. And Solidworks says it's 3/4 of an inch. Now I'm going to come over and I'm going to try the same thing in this view. Interesting. So here it's 0.75, here is 0.45. Which one do I believe? Well, I believe this view. You have to remember that when you're doing drafting, you're only measuring the distance in the view. So it's not the three-dimensional depth into the view, it's just the flat paper distance between the two entities. So I'm going to get rid of this. That's just not right. Now it would be really nice if we had a view where we could look directly at this face so that all the dimensions appear in their proper size. I'm going to get rid of this view now that we've done that little exercise. Oops, still in the command. And I'm going to do something called an auxiliary view. I'm going to choose the line I want to project from. And Solidworks drops in a view for me. Okay. I need to adjust some of the sizes and locations of the created items. This arrow bar shows the direction that my eye is looking in. So it says I'm looking directly onto this face, which is important. Because I know where I'm looking, I could put this view on a second page if I wanted to, and that would be perfectly legitimate. You just have to tell the reader where they're looking. Oops. There. It's a little nicer. And another thing, always make sure that your auxiliary views or any created views begin at AA. So I was in that note command. I'm going to click on View CC. There, that's what I wanted. We'll click on the view bar, which shows the direction of viewing, and I'm going to change that to A. It's our first one. Okay. So now let's redimension these holes. I'm going to go to the hole and to the edge, from the edge down. So notice that the 0.75 agrees with this 0.75 where we measured it in profile. And I can't leave it this way. If I did, it would be considered a double dimension. So I'm going to delete this 0.75 because it's going to the center line of a hidden object. So now that is correct. I have a 0.5 dimension to this hole coming off the edge. I could put another one here if I wanted to, or alternately, I could say that these two belong to a common pattern, and I could insert a center line between them to make that statement. And now I need the distance from an edge to the other hole. Notice that I'm trying not to cross these extension lines. Forgive the highlighting. But look at where my mouse pointer is. Okay, that extension line and this extension line. Trying not to cross it. And that's just to keep everything clean. Okay, so I'm missing my material thickness. I need to put that back on from deleting the previous view. Whoops. There we go. So let's see how we've done. I have the height, I have the width, I have the thickness. So that tells me how big a block of material I need. I've located the counterbore hole. I've specified the counterbore hole. I've located these two holes. I'm missing something. I need a hole callout. I'll go back under annotation, click on hole callout. Okay, now the machinist knows how to prepare that hole. Whenever you're doing prints, the best thing to do is just walk through all of the features on the object and make sure it has a location and any specification so that the machinist knows how to make it. I need a material callout, so I'm going to insert a note. Say notes. $6061 T6. So this is probably the most common grade of aluminum sold today. Very nice. We'll check our title block, and I'll get out of this notes command. So I have my name on it. I'm going to change the date by just double clicking. Today is 10/21/18. The view scale, let's get out of that command. Click on the view. So the scale is 1:1. Fix that scale. And it's only going to be a single sheet drawing, so I'll make that sheet 1 of 1. Get out of the command. I'll delete my second sheet by just right-clicking on the tab and hitting delete. There we go. Make sure that anything you don't use, you delete. Okay, so down here in the title block, if I needed to change any of this, as in the drawing title, the part number, or the revision, that's all being pulled from the model. So if I need to change any of that, I'll go back into the model properties. And this is the drawing title, the drawing revision, and the drawing part number. So if I need to change it to, say, Rev 3, I can do that. I'll say OK. I'll save it, close the part, and notice Rev 3 adjusts on the drawing. If I was actually doing a Rev 3, I'd have to come up here to the revision block and fill it out with whatever changes occurred going from Rev 2 to Rev 3. Okay. So that is how you do auxiliary views, folks.